So in the last lecture, we've also talked briefly about the example app I'm using. So there's a link to a GitHub repository. There's a Docker file in there. There's a source code file. Stupid me also checked in the binary, which doesn't make sense. I'll have to fix that at some point. But I've chosen this example as it is very, very minimal. So even if you don't know the Go language, it's a very simple application and you should understand what it does. So basically implementing just a hello world output. There's also a ping endpoint, but well, in a hello endpoint, I don't think we were using that. And it starts a web server on port 8080. Yeah, again, this isn't beautiful code. It's not meant to be a Go lecture, so it's just a little web application, simple enough so that you look at the code and immediately get what it's doing. All right, so let's create the first replica set. If you look into the replica set, you can see that there's a spec and it also says containers. So if you take the pod example from the previous lecture, so you can see that there's a spec and there's containers. So this is the same structure, which means that if as replica sets are a higher level structure and that they use pods underneath, you will see that the pod specification is basically also included in the replica set specification, and it uses the same attributes. Sometimes when you're new to Kubernetes, you might be wondering why those nested structures are sometimes a bit hard to read, but it gets easier over time. So in this case, we are using, again, this is an API version that's being declared. The object we want to create, because the Kubernetes API is responsible for many objects. Spoiler alert, you can also extend the Kubernetes API to manage custom objects. They are then called custom resources. And in order to tell Kubernetes about a new resource, you would create a custom resource definition along with a controller. So in Kubernetes, you always see here the field kind with a particular resource type. In this case, it is a Kubernetes native type that comes along with any Kubernetes cluster. It is the type replica set, and there's a replica set controller that is being invoked whenever an object of the type replica set has been created. So this is nice to know, because you may ask yourself, where in Kubernetes is the behavior implemented? And the answer is in the controller corresponding to the particular object type. So in this case, it's the kind replica set. The metadata section usually also contains a name, so that you can name the resource. So you can think about the replica set kind as a class in Java. And what we are doing here is we're specifying an object. So when you instantiate a class in Java into an object, you will have a variable name. And basically the name here is the variable name for the object for the replica set, for the object of the class replica set. We've also seen that labels are quite important. For example, if you want to filter the pods that have a certain label, you can do that. For example, we look at this pod, but it does not have a label, so we'll make this example later. Alright, so the spec of the replica set itself here, it says replicas 1. In this case, replicas means the number of pods you would like to create. In this case, the number of pods is 1. There's a match label because this pod belongs to the tier front end, which is, you could also create other key value pairs to identify your pods and your replica sets. So in this particular case, you can see that it makes sense to share certain labels along with the resources you create, so that you can always see that they belong together. So you could, for example, have a distributed system. The distributed system has front end and back end and maybe data service resources, and you could annotate them using labels to declare which of these components belong to which part of the distributed system, especially when using microservices where the number of services in a distributed system is rather high. It makes sense to organize deployments, and when performing updates and also during debugging, it's always good to be able to filter requests and select only those pods you really want to look at. Especially if there are many pods in a namespace, it may be much easier to have an overview if labels can be used properly. Labels and annotations, they often also carry semantics. So for example, there are add-ons for Kubernetes, such as the so-called sidecar pattern, where there's a container being injected into your pod when a particular label is present. So enough about labels, saying that they are used to organize your deployments. Metadata can be used to filter and apply automation selectively, and that you can at a later stage add add-ons or write your own add-ons that will also attach behavior to those labels. So it's not just a bit of metadata that sits there and does nothing. It also may be connected with behavior.